Hello friends, welcome to my YouTube channel. Today we are going to cover two topics. First one is transition function and second one is extended transition function. Okay. In the previous lecture we have discussed about the description of DFA and NFA, and we also have discussed the mathematical model where we have used 5 tuples, and those 5 tuples what? M, Q, summation, del, Q naught and F. See that these are the 5 tuples for define the FSM, and the FSM can be DFA or NFA. Okay, so we have two machines. First one is DFA and second one is NFA. If we want to define this for this tuples, so that is first DFA. In this case, Q. So Q is what? Q is a set of Q is set of what? States. So in this case we have 3 states, that is A, B and C. So A, B and C. So this is what? The set of states. And second is what? Summation. So summation is the input symbol. So in this case we have 0 and 1 as an input symbol. Next one is del. So this del is a what? Transition function, and we will discuss it later. Second, next is Q naught. Q naught is initial state. So in this case we have initial state as A. Okay. And last one is F. And F is what? The set of final states. So here we have only one final state. So we have this. So this is for the case of DFA, and for the case of NFA, Q is again here also we have 3 states, that is A, B and C. The input symbols here also we have 0 and 1. The initial state is A, and the final state here also we have B. So this is what? The final state. Okay, so these are the tuples and their values for this two machines. Okay, now this del is what? The transition function. So for the DFA and DFA and NFA, how we can show this? This transition function can be shown as a tabular form called as what? Transition table. Okay, this transition table is in set of input states versus input symbol. So how we can draw this? Here we have 3 states, A, B and C, and here we have input symbol. Okay, so this is input symbol, and here we have states. Okay, so from state A, for the transition 0, we are reaching to state B. So from A for 0, here we have B, and from state A for the transition 1, from state A for the transition 1, we are reaching to C state. And from the B state for the transition 0, for the B state for the transition 0, there is a state is C, and for the from the state B for one transition B, for one transition there is a self loop of 1. So that means from B we are reaching to P. Okay, and from C has a self loop of 0 and 1. So in both cases we will get what? C and C. Okay, so in this transition table, these are input symbols, these are state tables, and this is the initial state. So we can show like this, and this is our final state. Okay, so this transition table is for what? DFA. And if we draw the transition table for the NFA, that's for this diagram. So Here also we have three states, A, B and C, and we have 0 and 1. So this is our input symbols, and here you have states. So this A is a initial state and this B is a final state. So from A, for 0 transition, okay, so from A, there are two zero transition for the 0, that is there is a self loop, and from A to C. So from A, for 0 transition we have two states, A and C, and for the transition 1, that is from A to B. So here we have only B. From the B transition, from the state B for 0, from the state B 0, that is B to A, and for 1, so there is a self loop, and this transition from B to C, so we have two states, that is B and C. Now from the C state has self loop and no other outgoing transition, so we have what, C and C. Okay, see, this is more, there can be more than one state, so we have drawn in brackets. So this is a transition table for NFA, and this is a transition table for DFA. So this is how we can show the diagram in the form of a tabular form. These tables are what, the transition function or transition table. Okay, so that is how we can show DFA or NFA. So now let's move towards our second topic, that is extended transition function. See, before going to the extended transition function, first we need to understand that this DFA is a what, acceptor for a language. See, a language maybe maybe a collection of some strings. It is a set of strings, and those strings will be accepted by this machine. So if we want to write the language to is accepted by this machine, so this language could be like 0, 1 to the power n, where n is greater than or equals to 1. Okay, so this is how we show the language accepted by this machine. That means there is a 1 0, that is this, and we have more than one ones, that is there is a one self loop. So see this. See, there is maybe only single 0, or we have n number of ones at this B state. So this is how we can show the language accepted by this machine. Okay, so in this extended transition function, what we are doing is, if some string, if you want to show that whether the given input string is a part of this language or not, so how we can show this, like, so how basically how this works, that here we have current state, here we have input symbol, and then after this transition you will get next state. Okay, so like we have input string 0 1 0 1 1 1 0. So this is our input string, which we want to show whether this string is a part of this language or not. So we have del dash, that is the extended transition function. We have see, we will always start from, that is initial state A, we have 0 1 1 1 0. Okay, after the completion or scanning the whole string, if we are reaching to state B, that means this string is a part of language. Else if we are reaching to some non-final state, that may be C, so that in case you can say that this given string is not a part of the language. Okay, so how we can proceed here? Del dash, see, a current state is A, the input symbol is 0, rest we have what? 0 1 1 0. Okay, so what we will get the from this, that's from A 0 transition, you are getting what? B. So next state is what? B 1 1 1 0. Okay, so that is how we proceed, and similarly we can go through del B 1 dash, we have 1 1 0 del, so sorry, this will give me what? See, we have a self loop of 1, so here we get B 1 1 0 del B 1 1 0, you get B 1 0 del dash del B 1 0 del dash, again you will get what? B 0 del dash B, see, no, here del dash del B 0, here you have what? Epsilon, because no part of this thing is left, no here. So from B to 0 you will get what? C, and here is epsilon. So from C we are not doing any transition, that is epsilon, so at that stage you will finally get what? C. So final state after scanning the whole string, you are getting what? C. And if in the diagram the C is what? A non-final state. That means the given string is not a valid string, or you can say this string is not a part of this language. Okay. Now let's just take an example. If we remove this 0, now if we scan this, so we can like this 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 this, so this will not be happen. So here we will get what? Epsilon. So here you will get what? So here you will get epsilon del dash, this will give me what? V and epsilon. So from B, if you are not doing any transition, then you will be what? B, and this B is what? The final state. Okay, so after scanning the whole string, if you are reaching to final state, that means this string is a, sorry, this is what? Not valid, so this is a valid string. So, okay, so earlier this is not a valid string, but this is a valid string. Okay, so this is how we show whether the given input string is a part of this language or not, and that can be shown with this extended transition function. Okay, in the next lecture we will see that how we can convert the NFA to DFA. Okay, thank you.